Hello, we are Molibdênio and welcome to our technical video presentation.
Hello, I'm Gabriela. I'm responsible for the computer vision, communication, and Raspberry Pi's programming of the project.
Hello, I'm Oscar and I'm responsible for screen programming and scenery building.
Hello, I am Raisa and I am responsible for card system integration and electromechanics.
Hello, I am Sofia and I'm responsible for finish line programming and visual design.
The finish line was a big challenge because it integrates several technologies, such as pneumatics, communication, and the LED panel. That's why we chose it as a feature.
In addition to containing a visually captivating structure, it has a servo mechanic that makes the scoreboard appear, making visible LEDs which interact with the presentation.
The purpose of the finish line is to count the cards' laps by detecting their colors to know who is winning and when the race is over. Another mechanic presented in the robot is the pneumatic system that releases compressed air with colored ribbons when the winner crosses the finish line. It is also responsible for the communication among the robots in our performance, acting as a server.
Communication is essential for our presentation because it is responsible for integrating all robots by transmitting messages between them. To facilitate this connection, we have developed a class.
Through it, we developed a communication system in which all robots can send and receive messages among them. Here you can see the screen sending messages to Cart's Arduino, which is connected via cable to its Raspberry. They don't have a direct connection, but this one works as a sub-server, so it receives the screen message from the finish line and passes it to the Arduino to start the movements. Another example of the use of our class is when the finish line Arduino broadcasts a message to every robot to start the presentation.
Cards were also chosen as a feature due to the integration of different systems. We integrated the compass and gyroscope data through Kalman's filter to obtain more accurate information about the regulation of the cards, when we combined different data that move the cards by applying a proportional value and passing the results to the motors. The data are angulation of the robots, the player's actions, and the deviation to markers. The proportionality is to control each data's force, thus allowing the cards to not leave the limits of the stage. But when the robots turn, these values are cancelled out so that the turn will be not affected.
For steering the cards, we use a deep neural network, or DNN, which detects both drivers and their steering wheels and calculates in which direction the steering wheel is being moved. Our DNN was built using TensorFlow network. In it, we developed our dataset and trained our model using YOLO and TensorFlow itself. Both in cards and on finish line, we apply color segmentation. To facilitate the process, we use a class developed by us. We created it in 2019 and since then it has been improved. Here you can see the calibration process, where we select the color to be detected.
The screen is intended to show audiovisual elements with augmented reality to make the presentation more interactive. It can dynamically react to the events of the performance with video through Bluetooth, as shown in this example. Screen is manipulated by Unity Game Engine, responsible for showing virtual objects of augmented reality, along with Vuforia, used to keep track of the markers so we can build our virtual scenery.
The console composes the visual part of performance. Its goal is to start the presentation by inserting a card in it. This is accomplished by our RFID system, and with console is the reader and the card is the tag.
In the past competition, we received feedback about the need to develop more visual and mechanical elements, so this year we dedicated ourselves to adding as many as possible.
Therefore, we chose design as a feature because it makes the performance more understandable and immersive to the public. Both the use of pneumatics and the scoreboard with its LEDs were resources to make the performance more attractive. Because of the size of the scenery, it was designed to be easily transportable through foldable designs.
Many changes has taken place in our project.
In the case of finish line, we had some setbacks regarding the identification of the card's colors. On the HICV color scheme that facilitates segmentation, the red and yellow colors chosen for the robots were shown as similar, and for this reason we had to change their colors to avoid possible confusions. However, during the tests, other challenges appeared, and so we adopted as a solution a screen division for each card on the finish line, and we used morphology in the segmentation class.